Good day po to all our participants, and thank you for joining us today for this online seminar focused on mechanical calibration and sealing of fuel dispensers. I am Daniel S. Malvizo from the Energy Industry Management Division, Department of Energy, Mindanao Field Office. Mechanical calibration involves the precise adjustment of fuel dispensers to ensure that they deliver the correct volume of fuel, while sealing is essential to maintain the integrity of the calibration by preventing tampering. Together, these processes are critical in upholding the standards that our industry relies on. Without further ado, let's proceed with the topics for this session. Here is an outline of our presentation. We'll begin with an overview of the parts of the fuel dispenser. I'll introduce the various components which will help us later identify the key parts involved in calibration and sealing. Next is the different types of meter. Following that, we'll delve into the main topic, mechanical calibration and sealing. Then lastly, we'll wrap up by discussing the different types of mechanical wheels. First topic is parts and components of a fuel dispenser. First is the electronic board. This is where all the electrical component is found, usually located in the upper part of the fuel dispenser. Next is the pulser, component responsible for converting the mechanical movement of fuel meter into electronic signals. Next is a valve which regulates the flow of fuel. Then, meter, a device responsible for measuring the precise volume of fuel that flows through the dispenser into the vehicle's tank. Pumping unit is a device that draws the fuel from the underground tank. Motor is a device that drives the pump that moves the fuel from the underground tank to the nozzle. So another diagram for the general components of fuel dispenser. First is the keypad. It is usually located in front or in the side of the fuel dispenser where the pump operator inputs the volume or the amount desired by the customer. Next is the display, which is usually in front and displays the amount, the price, and the volume desired by the customer as well. Next is the controller or CPU located inside the upper part, the AC/DC supply, the pulser, the solenoid valve, then the meter. For fuel dispensers with mechanical calibration, this is where we adjust. Ito po yung part. If you can see on the right side, the wheel with holes, dyan po nag-a-adjust. Depending, the adjustment depends on the legend engraved in the meter, but later it will be discussed. Next is the filter for the fuel incoming, the pump which draws the fuel from the underground tank, the junction, and the motor. Then let's proceed to the different types of meter. So there is a Tokheim type. This is the part where the calibration will be done. Next is this one. This is on mechanical calibration only, so we adjust here. Next is the Tatsuno and Tatsuno-like. So there are no holes on the side because this has electronic calibration, which will be discussed on the another topics. And also this one, the Gilbarco VR. If I'm not mistaken, it's here on the upper part being sealed. So this is the Tokheim type. according sa description, if under delivering, turn the upper dial clockwise. So, ang orientation po ng pag-increase ng kanyang volume na dumadaan sa kanya is you need to rotate it clockwise. And this one is very common if the dispenser is purely mechanical. So the orientation instruction is here engraved sa upper part. So for this particular meter, ang plus is going that way. So increase going that way, or counterclockwise. And if you need to decrease, you will be going to rotate it clockwise. But based on experience sa field, not all the times na tama yung naka-engrave here sa meter. So we need to do trial and error for if you found it during inspection na magkaiba yung ginagawa niya based sa pag-dispense natin sa calibrating bucket over the engraved na instructions sa meter. Next is a Gilbarco. So Gilbarco is electronic, but there's a knob in the upper part that is being adjusted, being turned into calibration mode. Tapos ina-adjust na siya through keypad. Then for Tatsuno or Tatsuno-like, wala kayong makikita ng mga holes on the side because this is purely electronic. Let's proceed with the mechanical calibration procedure and sealing. So for this topic, we'll be only focusing those fuel dispensers with mechanical calibration procedures. So those meters with a rotating wheel with holes. So this is an example of that. So as per the engraved instruction, the plus is on the counterclockwise. So if you want to increase, you need to rotate it counterclockwise, and if you want to decrease, you need to rotate it on the other side or the clockwise. So here's an example. May naka-engrave na increase and decrease. To increase the flow, if under delivering, we need to rotate it counterclockwise. Then, to reduce the flow, if over delivering, we need to rotate it clockwise. Okay, let's have an example. So, we dispense 10 liters sa calibrating bucket. Then, ang resulting reading is negative 50 ml. Though it is still in the maximum permissible error, we still need to return it back to zero. So gagawin natin is we will adjust the calibration sa mechanical wheel because we are only focusing on the mechanical calibration. For this type of meter, ang naka-engrave is plus is counterclockwise and minus is clockwise. So we need to turn it counterclockwise. Let's assume na ang hole niya is 10 ml. Ang value ng per hole is 10 ml. So why do we need to have an assumption? Because sa iba-ibang meter, iba-iba rin yung value ng holes. And siguro sa sobrang dami ng mga gasoline station na iba-iba yung brand, iba-iba rin yung value ng holes. That's why it's hard for us to memorize, and also there are factors affecting the adjustment of the holes. Maybe ngayon 10 ml yung value niya, but due to time, may mga wear and tear, nagiging 8 na lang siya. That's why in mechanical calibration, we need to do trial and error. So for this one, we assume that the hole is 10 ml. So kasi under tayo ng negative 50. Nag-under tayo ng negative 50 dun sa first example. So what we need to do is to rotate the mechanical wheel clockwise sa 5 times. 5 holes ang kanyang distance. After natin mag-adjust, mag-dispense tayo ulit ng 10 liters. Then after 10 liters, we need to read the calibrating bucket. This is now the new reading. So, the initial reading is negative 50 ml. Now, we have exact 10 liters. So, the difference of our initial reading and our final reading is negative 50 ml. Actual adjustments is 50 ml, which is 50 ml divided by 5 holes, 10 ml per hole. So, our assumption na kanina, earlier, na ang hole natin is 10 ml is the same with our actual adjustment. So, further adjustments, wala, because we successfully return the calibration into 0. Now, let's go for another example. Case 2, brand B. The same po, under delivery ng negative 50 ml. Katulad ng kanina. So, our assumption, let's say, the same lang po kanina. Assumption of 10 ml per hole. So, we need to adjust it 5 times. 1, 2, 3, 4, and 5. Then, here, assumption, hole 10 ml. So, after that one, we need to dispense ulit sa calibrating bucket to check the final reading. So, our initial reading is negative 50 ml and our new reading is negative 12.5 ml. So, for the information of everybody, this calibrating bucket, ang value per line, that one is 12.5. So, 12.5, this one, 12.5. Then, the second line is 25. The third line is 37.5. And the fourth line is negative 50 ml. So, balik tayo sa example. The actual change or the actual adjustment is 37.5 lang. Kasi minus 50 minus 12.5 ml is 37.5 ml. Therefore, 37.5 ml divided by 5 holes, ang value per hole is 7.5 ml. So, may kulang pa na 12.5 ml. For further adjustments, kasi sabi, based on our trial and error, ang hole daw is 7.5 ml per hole. So, we need to add 2 holes, which is 15 ml. An additional of 2 holes para ibalik ang calibration into 0. Here. So, another example for brand C, under delivering of 50 ml. So, adjust tayo ulit. 1, 2, 3, 4, 5. So again, let's assume na 10 ml per hole. Pero ibang brand na to, brand C na. So we dispense 10 liters to know ano ang actual na value per hole. Ito. our initial reading is negative 50 ml. Then our final reading is positive 12.5 ml. So above siya sa 0. So the difference or the adjustment is equal to 62.5 ml. Kasi 50 ml downwards plus the 12.5 ml. So actual adjustment is 50 ml plus 12.5 is equals to 62.5 ml. Then 62.5 ml divided by 5 holes, ang value per hole for this brand C is equal to 12.5 ml. For further adjustments, we need to deduct hole 12.5. So into clockwise direction naman. Isang hole. Another example, so nag-dispense tayo ulit ng 10 liters and the reading is minus 75 ml. So assumption is 10 ml per hole, so we will adjust it 8 times. 8 times into counterclockwise direction. After adjustment, we will dispense another 10 liters to the calibrating bucket to check the new reading. So initial reading natin is minus 75. Then the new reading is plus 25. 100 ml, the adjustment is 100 ml. Therefore, 100 divided by 8, so ang value pala ng holes are 12.5 per hole. 12.5 ml per hole. Kasi sumobra siya ng ng plus 25, we need to adjust it para mabalik sa 0. So we need to rotate it clockwise 2 times. Again, initial reading is minus 75 ml. After adjusting it 8 times, because we assume 10 ml yung value per hole, the new reading is plus 25 ml. Therefore, may 100 ml adjustments. So 100 ml divided by 8 holes, the actual value per hole is 12.5 ml. Then we need to rotate it clockwise twice, because 25 divided by 12.5 is 2, para mabalik siya sa 0. Let's try calibrating bucket with different scale. So the scale of this particular calibrating bucket is 3 ml per hole. So the value of that per line is 3 ml. Therefore, the initial reading is negative 54 ml. So let's assume again na 10 yung value per hole. So we will adjust 5 times. After adjustment, mag-dispense tayo ulit ng 10 liters sa calibrating bucket. And our new reading is, our initial reading is minus 54 ml. Our new reading is minus 9 ml. So the adjustment is equal to 45 ml. Then solving for the actual value of the hole is 45 divided by 5 is equals to 9 ml per hole. So this is the actual adjustment. The 9 ml per hole. Then, as you can see, hindi pa siya bumalik sa 0. So, still need to adjust it counterclockwise para mabalik na ang reading sa 0. So, another type naman ng calibrating bucket. This one is, the scale is 10 ml. So, let's proceed with this example. Initial reading is 130 ml. So, pag-dispense natin sa calibrating bucket, we found out na ang kanyang reading is 130 ml. Then, assume whole value is 10 ml. So, we will adjust it 13 times. After that, we will dispense again sa calibrating bucket and check the new reading. So, the new reading is plus 40 ml. So, this is the 0 or the baseline. And then, so, solving for the actual adjustment or actual value per hole is 170 divided by 13. So, ang value pala is 13 ml per hole. So, 40 divided by 13, so we need to adjust it 3 times. So, clockwise to decrease. Para mabawasan yung calibration, we need to rotate it clockwise. Next, this one, scale of 20 ml calibrating bucket. So, nag-dispense tayo sa calibrating bucket and we found out the reading is minus 180 ml. So, our assumption per hole is 10 ml. Kaya we will rotate it 18 times. After the adjustment, mag-dispense tayo ulit sa calibrating bucket to check the reading. So, as you can see, the reading is in between the 0 and the 20 kasi the value of this line is 20 ml. So, we can say na ang value ng pangalawang reading is minus 10 ml. So, solving for the actual value per hole is 170 divided by 18. So, 9.4 ml per hole. To adjust it balik sa 0, we need to rotate it 1 time into clockwise direction. Counterclockwise direction. Kasi kulang pa siya. Let's move on to the typical meter accuracy curve as outlined by NIST in the United States. When evaluating the dispensing capabilities of a fuel dispenser, the DOE conducts tests in 3 different modes: the slow, medium, and fast. Then according to the graph, the slow mode typically results in over-delivery or over-register, while the fast mode tends to under-deliver or under-register. To account these discrepancies, all 3 modes should be tested, and the reading for each mode, the reading for each mode should be averaged, and that will be the basis for if it is within the maximum permissible error. Let's have an example. So for the first nozzle, the fast flow reading is minus 25 ml. Then medium is 0 ml. Then slow, plus 25 ml. Average of 0, which means it is exact 10 liters. Then the remarks may not need further recalibration. For number 2, second nozzle, the fast flow is minus 75 ml, the medium is minus 50 ml, and the slow is minus 25 ml. The average of minus 50 ml. So the remarks is need to readjust the mechanical wheel or electronic calibration parameters. Average result shall be almost zero error. Though it is still within the maximum permissible error, it is important that the calibration is returned to zero, ensuring that the dispenser, ensuring the dispenser is zeroed helps provide fair and transparent transactions for our customers. And we're down to our last topic for this session, the types of sealing of mechanical wheels. There are two types of sealing of mechanical wheels. First is a meter face with hole and meter face with no hole. The pictures that will be shown on this presentation is courtesy of CSI Global Services Incorporated. For type 1, you can easily identify it based on the side view picture of this meter. So, may hole siya, engraved, may parang built-in hole siya sa meter. Then, there's also a rod with a hole. Make sure that both of them, the step 2, will be aligned. Because this is where you will insert the seal wire. So after inserting the seal wire, you can also insert it dito sa mga built-in na holes sa wheel para to give it another support para di siya madaling matanggal. Then after na-attach, na-insert na yung wire doon sa face hole sa rod at doon sa mechanical wheel, you can now insert the seal and press it. This type of seal should be pressed. Else, it will be the purpose will be defeated because pag natatanggal yan, pwede lang tanggalin ng mga technician ng mga gasolinahan. So, just make sure na nakapress talaga siya palagi. For the type 2, no face hole. So, the side view, wala kayong nakikita na butas. But there's specific rod. Yung rod na yan is may butas siya. So, pwede nyo i-insert yung copper wire or aluminum wire dun sa rod, tapos i-insert nyo yung other end niya dun sa ibang holes. Just make sure na hindi siya natatanggal or hindi siya nagagalaw. Then after making sure na properly tangled na siya, then you can insert the seal and then press. So that's the difference between the two for the mechanical wheel. I think that ends my presentation. So for more information, you can follow us at the DOE Mindanao Energy Industry Management Division at Facebook, and you can also contact us with our may mga cellphone number kami. I think there are 3 and the 1 telephone number. So for more information, you can also email us at doe.mfo@doe.gov.ph and eamd.doe.davao@doe.gov.ph. Thank you and keep safe.